Alright, welcome back to Ox Tools. I'm Tom. So we're still working on this steady rest. There's a bit of work left on it. I finished the drilling and tapping off camera of the roller guides. I showed the first one, so I don't want to suck up bandwidth just showing common operations like that. I'll save the special stuff. So these are both drilled and tapped here and ready to receive the roller guides on both sides here. While I got this, at least I thought of it, I was pretty proud of myself, I remembered. I got to cut a little 90-degree notch right here. And what this does is it registers with the ways on the lathe. And what I did was I had laid this out and described it from this other piece that fits the ways too. So while I have this vise at 90 degrees, I'm going to go ahead and cut that out too, and while I'm at it. And so it's a little bit different setup. I'm going to show a different way of using, of getting this angular setup correct. That's of general interest. So we'll go ahead and do that. So this particular setup, like I said, I got it scribed here. I can see it. So I need to be in the vise like so. Get up there, and this surface is going to be 45 degrees to the machine table. So, you know, this eyeballing it there, somewhere in that region right there. So a couple ways we can do this here. What I'm going to do, like I said, I'm going to show you a different way. So I want this surface to be 45 degrees to the world here. And a tool that I bought, I don't know, maybe 10 years ago that I've actually found all kinds of interesting uses for is this electronic level. Let me grab it real quick. So this is this SPI Tronic electronic level. I'm sure there's other makes and models out there, but the cool part and the part that I'm was very interested in is when you turn this on. So I can put it on the table here, and it's actually telling me well, actually pretty good right now. I don't think this mill is perfectly leveled. It's pretty close, but I've moved it around a couple of times. But anyway, the interesting part is I can set an alternate zero. So, for example, you know, I could call that 0 and then measure something in relation to that. Okay, which is the very interesting part here. So what I'm going to do is I'm going to put it on the table here, which is what we care about. Or actually, let's do it up here maybe. That's probably just as good here. So let's let it settle out. So it's saying, you know, about 1/10 of a degree, something like that. So I'm going to go ahead and hit the alternate 0 button, which should zero it out nicely. Okay, and I get the little flashing light that says I'm zeroing. So then I'll put it on this surface here, and it says 46.3 degrees. Okay, and we want that to be 45, so I'm just going to hold on to that. And this is one of those operations where 45.1, 45.0. See if I can get it to stay there. All right, it says 45.0 still. Get a little pressure on there. Okay, so you saw that was pretty quick, right? Okay, let's turn that off. I don't need that anymore. So, but I want a pretty accurate angle here. So what I'm going to do is I'm going to clamp a 45 degree, gloves died, 45 degree block there, and then I'm going to indicate that and then check it with an indicator just for, you know, thoroughness. Okay, so. Clamp just a piece of material here, so I got something to clamp to. that. Grab a 45. So this is just your standard 45-degree parallel. We're just going to put that on like so. Speed that up a little bit. Something like that. So that's nice against there. I'm holding it against there and I'm snugging it down. So now that's registering against there. So I'm going to indicate along here with the y-axis and see what we get. Okay. So, wow. So I don't need to do anything. It's that good. So, you know, I almost don't believe it, right? So, but the indicator's bearing against there. Running on the parallel. Let's just double. Okay, I'm done. So you can see that, that this little guy right here, potentially for weird stuff like that, is a pretty good time saver. And on the blog, I wrote a little article about using these with the tilt table. I'm not going to drag that out right now. Go read the blog. It's all got an article about the tilt table. But you can set the angle on the tilt table, and this resolves 1/10 of a degree, but I believe it's better than that. And so if you need some oddball angle or whatever, it's a quick way to set it up. And that alternate 0 is very handy because I can compare a surface that's not necessarily level with another surface and measure the relative angle between those two. And that's what got my attention when I saw this a long time ago, and that's really what I've used it for. I rarely use it as a straight up level. I have other levels that are that I like better for just you know machine leveling and things like that. I mean, okay, come on, it's an aluminum body, right? I mean, to me, this is not a tool maker type tool, right? You know, aluminum wear surfaces, give me a break, right? But it's valid. It's got a little V groove. You can put it on a pipe, and like I said, I don't use it like a millwright would use a level, you know, all day long. I just pull it out once in a while for weird stuff like this, and you know, you can see how quick that went to indicate that. So anyway, worthwhile to talk about it. So I figured I'd bring you in for just a closer view of this. Now, you know, believe what you want. I didn't pull any funny business there to make it come out good. You know, you can see how good that is, and you know the indicator is bearing against there, as you can see. So that's with that electronic level. So you heard that hum when I started the cut, so I slowed the speed down a little bit. It found a resonant frequency that I adjusted the speed maybe 10 RPM, something like that, to get rid of. And that's what that was about. I got some scribe lines here I'm watching and getting up close to them, and then I'll switch tools to a finishing tool. Well, that's close enough on the bottom one. The upper one I could sneak up on a little more. Alright, that's about as close as I'm going to get to those with the roughing tool. Okay. Alright, I got a finishing tool in there. 5/8 diameter, 5 flute, carbide end mill. I use this one a fair amount because it's got a 5/8 shank, and my all my drill chucks have a 5/8 shank on them, so it saves a collet change for us guys that don't have the cool pneumatic drawbars. Alright, so that's so what, 5/8 diameter, what is that, 16 millimeter or something like that, and we are running about what, 1200 RPM, something like that. So I'm just grazing this surface here. Basically, I'm just looking for a good registration right now. I got the Z pretty good. So I'm starting to cut that little bottom intersection. Looks like I got the vertical wall there. Alright, so I pretty much cleaned it up. I'm going to take a couple more thou coming back the other way. Alright, it's looking pretty good. Alright, so before I forget, let's zero that Y, and I'm going to zero that X, or Z, excuse me. And we'll take some measurements of that, the depth of that, that thing there. Alright, so we're going to check the depth of this. I think I'm to depth. I just wanted to show you guys how I'm measuring the depth of this. The depth of this slot, or this V groove here. So we're dropping a gauge pin in there, and then with a depth micrometer, we're measuring the depth. I'm looking for 510 to 511. Centered up there. 512. Okay, I'll take that for $1. Okay. And the idea is to match the V groove on this guy here, and then I'll cut a relief in it afterwards also. Alright, so our next problem, so these are the two sections. They get attached together, so they have a nice wide base that sits on the machine. But what I want to do is I want these V's that register with the machine weighs. I want those to line up really good. So I gotta do a little horsing around there to get those to line up. Anyway, so I'm gonna do that in the vise here, and ultimately these are gonna get welded together. But what I want is a good mechanical connection. I don't want to just like line them up and start welding on them. So I want to bolt them together first, and then I'll do a little bit of welding after they're bolted together. And the bolting will just act as clamps, permanent clamps, to kind of hold the whole mess together for the welding. And I'm not going to weld the heck out of it. It's just enough to really make it a permanent, unmovable assembly. So what I did was I put a couple of counterbores in here for half-inch screws, 12 millimeter screws, something like that. Now what I have to do is I have to put the corresponding tapped holes in this guy here, and but I don't have a good way to transfer these from this, but I just picked up a kind of a scribe center line and then drilled these holes, and I really kind of want these to be fairly accurate. So what I'm going to do is use one as a reference for the other. So what we'll do is get this up in the vise. A little bump on there. Alright, it's going to go in like this. Something like that. Okay, and then what I'm going to do, I'm going to change the camera and get in a little closer so you guys can see this. Alright, so this is going to go here like so, but what I want to register is this V groove here real well. So I think what I'm going to do is I'm just going to get a ground pin and put that in there and use that to register those two surfaces together. And this is a gauge pin here. It's a 1-inch gauge pin. And I'm just going to clamp this in the lower section. Maybe. Okay, so that's touching at the top, touching at the bottom, and then so this will go up like so, and then register against that pin real accurately, and then I'll reference these two sides together. So I need a clamp and I need a little fence. This will be my little fence here. Just a little stop to that'll work. When I put that up, oops. A little bit. Alrighty. Let me grab a C-clamp and then I'll clamp the two together. Then what I'll do is I'll just indicate one of these holes, and then I have my reference back from these holes so I can transfer it to this accurately. Anyway, that's the plan anyway. Alright. Something like that. Alright, this is when you wish you had an apprentice. Alright, that feels good. That looks good. Feels good. Okay, so I'll just pick one of those holes up, and then I can pull that off, and I can drill and tap my mounting holes. And I'm just using this as a template to transfer to the other. That's all I'm really doing. Oh, what do I want here? Larger chuck. Okay. Indicator. See that? That clamping away. Oh no, you can see it. Okay. All right. And once again, I'm just kind of eyeballing this to kind of get it within the range of the indicator. It's looking pretty good. Drop in there. This thing shifting gears on me here. So I still have a reference off of my back jaw, so I'm really only care about the X direction here. In this case, I'm going to try to ignore the other direction. Call that tasty.
Like thousands and thousands and thousands of boneheads having such a blast. I didn't get to spend as much time with you guys as I wanted to because I had to be on the air
Right.
on stage.
Okay.
From
Let's get this stuff off.
I was actually technically on the air when I sneaked on stage to watch Night Ranger for a little bit, and that is when Jack Blades asked me to dance. He's like, "Go dance with me." I'm like, really? Are you kidding? He wasn't kidding. No, he was really cute, and we had a good time. And just as I was walking back off stage, he's like, "Hey, where are you going? You should come sing with me." I was like, "Don't go sing. You know that." Of course, I know the words to Sister Christian. You know, I know the words to most Night Ranger songs.
And the center distance is 5 inches. Double check it. Yep.
business training and assistance. To find out how we can help you grow your brand and small businesses, visit wellsfargo.com/talk. Because when people talk, great things happen. Wells Fargo. Together we'll go broader. Wells Fargo Bank it is.
Never play poker with a guy named Lucky. Never hit a pinata that is.
All right. So that should do it. Let's get that other piece on there. All right, I'm pretty happy with that. Just the field test there. We'll lock this together. There you go. Anything else I need? Nope. All right. So needs a hole here, and we're getting pretty close now. We'll try it out on the lathe. Okay, that's the idea. Nice. Okay, getting closer.